Here we have our next lesson, order of operations. And this lesson is actually going to be a review for you. Not because you've done it with me yet, you haven't, but because order of operations is a standard that's met in both 6th grade and back in 5th grade, so this will be very familiar to you. In this lesson, we only have one vocabulary term, and it is the same name as the lesson, order of operations. And the definition of order of operations is the set of rules that we follow to evaluate expressions that involve more than one operation, meaning you are adding, subtracting, multiplying, dividing, doing more than one of those in the same expression. Here, Pemdas, this I'm sure you've also seen before. Pemdas is a way to help us remember the order of the operations, the order that we have to follow. If there are parentheses, that's what the P stands for. If there are parentheses in an expression, we have to go right to those first. Next, we take care of exponents. Now look, I have a slash here between the M and the D, between multiply and divide, because you either multiply or divide. And what that means is, if you have both of those operations in the same expression, multiplying and dividing, you do whichever one comes first. And then the last two will be adding or subtracting, and again, this depends on which of these comes first. Here we have the first of our three examples. Here we have to evaluate the expression 28 minus 63 divided by 7. And I just want to draw your attention to the two operations. We have to subtract and we have to divide. And if you think of the word Pemdas, D, divide, comes before subtracting. So we have to look at the 63 divided by 7 first. 63 divided by 7 is 9. So we simplify our expression by we bring down this 28. So now instead of 28 minus 63 divided by 7, we have 28 divided by 9, and minus 9. And 28 minus 9 is 19. So our final answer is 19. Now here on the bottom, it's a little different. We have a fraction, and I always tell you that fractions are division problems. But here we have to actually simplify the numerator and the denominator first before we can go ahead and do our division. In our numerator, we have 70 minus 9.2. That leaves us with 60.8. 3 plus 5 is 8. And as I said, fractions are division problems. 60.8 divided by 8, that gives us 7.6. And that is our answer. Let's look at the second example. Sometimes we're given the value of variables in an expression and then we have to substitute. 2 times the quantity, that's how we refer to any set or any expression that is within parentheses. 2 times the quantity x minus y squared. Now the first thing that we're going to do, as I said, is substitute. So we will rewrite our 2. We open our parentheses. Our x is 14. Our y is 2. And then we have this exponent. Pemdas dictates that we go to our parentheses first. So this 2 stays exactly the same for right now. I'm just going to bring it down. 14 minus 2 is 12. And we have our exponent 2. Now it's important to remember that this exponent belongs only to this 12. We have to take care of the exponent first, and then we multiply. The E exponent comes before M in Pemdas. So this 2 still just comes right down. 12 squared, so that's 12 times 12, is 144. 2 times 144 gives us a final answer of 288. Our last example. Now this one's a little bit more challenging, but we are going to apply what we have been practicing in order of operations to this area problem. Now what we have here is an irregularly shaped figure, and I say that because it is not a square, it is not a triangle, nor is it a rectangle. And what we have to do before we do anything is cut this. We have to divide it into two separate rectangles. Then we will find the area of each piece and add them together to get the total area. Now we can either cut it horizontally. I'm going to make a cut right here. We have to find the area of this rectangle and then this rectangle and add them together. But we can use order of operations to do that. Now you remember that the formula to finding the area is length times width. So what we're going to do is to combine both of these area formulas into the same expression. So the area of this total figure will be the area of, we'll call this rectangle sub 1, plus the area of rectangle sub 2. We'll call this R1 and this one R2. And now what we are going to do is substitute in our measurements. The length of this rectangle here. Our length is 6 meters. We can see that right there. To remember our units. And our width is 5 meters. And we're going to add to that the area of this rectangle. Now this one, the measurements are not as clear cut because our length, as you see, is not labeled. But we do have some information that will help us to ascertain what the length is. We know that from one corner to the next, on the longest side, we have a total of 16 meters. We also know that part of it is 6 meters long. So the remaining piece is 6 subtracted from the whole, from 16. 6 from 16 gives us 10 meters, and our width is 8. Now let's take a look at what we have. We have 3 operations here. We have multiplication, addition, and multiplication. So we're going to take care of the 2 multiplication pieces first, pardon me, and then add them. 6 meters times 5 meters is 30 square meters. And we're going to add to that 10 meters times 8 meters, which it gives us 80 meters squared. Our total area for this irregularly shaped polygon is 110 square meters.